Welcome everybody back to Through Inquisitive Kids. So in this video we will be starting our topic on working problems, and that's about the best title I could make it. But there are two important key points that I want you to know about. So the first one is the equations we're going to be using. So working problems are basically when you have a project or a task that two or more people work on it together in different ways, and there's three main values: the result, like what is the progress, how much you did at the end; your time, which is how long it took to complete the task; and efficiency, which is the rate you use you doing that task, which is sort of like how many widgets you create per second, right? How many nails you assemble per minute, that sort of thing. So you can think of it as a sort of itinerary problem, actually, because remember how we have distance is equal to time times speed, or the distance is equal to the time times rate or velocity. Well, these are really similar because the distance is the big total, the same thing as a result. We both have time, and the speed and efficiency is sort of the same thing because you have a number of result per time. Okay. So let's first dive into the problem, and we'll discuss the second key point later. Okay, Mr. Smith and Mr. Johnson are working together to build a small treehouse. Working together, they can finish the treehouse in 6 days. If Mr. Smith worked on it for 5 days alone, then Mr. Johnson taking over for 3 more days, they would complete 7/10 of the entire treehouse. If they each worked on the treehouse by themselves, how long will it take each of them to complete the treehouse? So the first thing is, let's analyze the information we have. We know that if they work together, they finish the treehouse in 6 days. But if Mr. Smith worked on it for 5 days alone, and Mr. Johnson worked on it for 3 more days, they would complete 7/10 of the entire treehouse. So we have 7/10 of the entire treehouse, but do we know what is the value that the entire treehouse represents? Like maybe how many square feet of wood they have to cut, or how many nails they have to create or buy, or something like that, or manufacture. Well, we don't. So what we can do is set the unit 1, and we talked about this in our last topic, fractions and proportions as well. The unit 1, or the unit 1 whole, is basically the biggest value that can be applied to any smaller situation that you can write relationships and equations off of, that never changes. So that 1 whole, in this case, would be representing the entire amount needed, the entire treehouse, right? Because we have fractions, we have times, but we don't have the total. We don't have this part right here. So in this case, the treehouse will be our whole. Now, I'm going to set S and J. Well, actually, let me first color this blue just to match. Okay. So we have 2 different people working on this, Mr. Smith and Mr. Johnson, right? And they work at 2 different speeds that are constant, or should I say efficiencies. So we know that added together, they can finish the treehouse in 6 days. So in here, 6 days is the time, and 1, right? We already said our unit 1 whole. That's the entire treehouse. That's the result. So their speed would be 1/6, right? That's efficiency. The efficiency would be 1/6, the result divided by the time. So 1 divided by 6, 1/6. Okay, so S plus J is equal to 1/6. S in here is equal to efficiency of Smith, and J is equal to the efficiency of Johnson. Just write John. And if Mr. Smith worked on it for 5 days alone, so 5 days alone, so in those 5 days, the final result would be 5 the time times the efficiency of Mr. Smith, which is S. And then Mr. Johnson taking over for 3 more days. So the time, 3 days, times the efficiency of Johnson, which is J. That is equal to 7/10 of the entire project. So basically we're being asked if they each worked on the treehouse by themselves, how long it would take each of them to complete the treehouse. Well, in order to find that, we need to first find the speeds, the efficiencies of Smith and Johnson, right? Because if we're going to find how long or the time, we need to first know the result and their efficiency. And we already know the result, that's 1 whole. So all we have to do is find their efficiencies. And we can do that by solving the system of equations right here. So how I like to do it is to substitute equation 1 into equation 2. So if 5s plus 3d is equal to 7/10, but we know the sum, we could turn equation 2 is equal to 3 times s plus j plus 2s is equal to 7/10, right? And we know that s plus j is 1/6, so we can substitute that in here. And we would have 2s is equal to 1/5, and s is equal to 1/10. So if s is equal to 1/10, let's substitute that back into, say, the first equation. And so 1/10 plus something is equal to 1/6. So then what would j be? Well, j would be equal to 1/6 minus 1/10, which is equal to 1/15. So we know the efficiency of Mr. Smith is 1/10 per day, and 1/10 of the entire treehouse per day. And the efficiency of Mr. Johnson is 1/15 of the entire treehouse per day. So we can do 1 divided by their speeds, which in this case would be 10, and 1 divided by 15 is equal to 1/15 is equal to 15. So our final answer is 10 days and 15 days. So here the main thing right here is to create the equations off of what you know by the unit 1, right? And just really paying attention to the values you need for this equation. If you're going to find the result, you got to know the time and the efficiency. If you want to find the efficiency, you got to know the time and the result. If you want to find the time, which in this case, then you have to find the efficiency and the result. So thank you for watching through Inquisitive Kids, and see you in problem 2.